Today's lesson is on analyzing functional graphs. We're going to look at the domain and range, determining the x and y intercepts, finding zeros, finding the intervals of increasing and decreasing, and finding the end behaviors. Let's look at two graphs now and determine their domain and range. Let's look at the one on the left first. We call this piecewise function. Domain is the x values. So what are your x values here? They're going from -4 to 5. Write it as interval notation. Since we have closed circles on both ends, we have brackets. Now let's write this as a compound inequality. X in the middle, less than or equal to -4, less than or equal to 5. You could write the domain as either this way or this way. Could see either, they mean the same thing. Now let's look at the range. Range are my y values. What's the smallest y value? Well, how low does it go? -6. I'm going to write it as interval notation first. How high does it go? 3 is the highest. Closed circle on both ends, so we got brackets. So we say from -6 to 3. Let's write it as a compound inequality now. Got less than or equal to on both sides of the y. Smallest number, biggest number. So y is between -6 and 3. So the range is between -6 and 3. Okay, let's look at the other one. Domain. So your x values. What's the furthest left we go? -4. Right is +4. -4 we have open circle. +4 we got closed circle. Write it as compound inequality. If just less than a -4, less than or equal to +4. Now let's do range. What's the lowest we go? 0. Highest we go is +4. Closed circle with 0. We have an open circle and a closed circle with 4. We're going to use closed. Write this as a compound inequality. Y is between 0 and 4, so the range is between 0 and 4. Now let's do x and y intercepts. Graphically, we determine the value where the graph crosses either the x-axis or the y-axis. Arithmetically, we find the y-intercept by plugging in 0 for x and solve for y. And then to find the x-intercept, plug in 0 for y, solve for x. So let's look at one. We have an example. Y equals the absolute value of x. Subtract 4. I've graphed it, so we can do it graphically. X-intercept. -1.5. +1.5. Let's look at the y-intercept. Where does it cross the y-axis? Only one time. -4. Let's look at another example. Now this one's only linear this time. Y equals 2/3 x subtract 2. X-intercept. Where is it across the x-axis? Right here. The x-axis is x-intercept. Oh, we have a wrong graph here. Let's graph this. We have y-intercept -2. Go up to right 3, up to right 3. Here's my line. Where's it cross the x-axis? +3. Where does it cross the y-axis? -2. So my x-intercept is 3. My y-intercept is -2. Now let's do it. Let's find the x and y-intercepts algebraically. To find the y-intercept, we take 0 and substitute for x. Now what is the absolute value of 2 times 0? Subtract 1. Subtract 3, we got -2. To find the x-intercept, we take and plug in 0 for y, and we solve for x. Remember, we have absolute value, so we need to make 2 cases. 2x subtract 1 equals 3, or 2x subtract 1 equals -3. There, x equals 2, and x equals -1. So we actually have 2 x-intercepts, which means this graph crosses the x-axis plus. Got a second example. Y equals 3x subtract 4. On the y-intercept, we substitute 0 for x. 3 times 0, 0 subtract 4 is -4, so my y-intercept is -4. On the x-intercept, we substitute 0 for y. Then we solve 0 equals 3x subtract 4, and we get x equals 4/3. Look at this function. What are the x-intercepts? Well, let's look. Where does it cross the x-axis? 0.5, -4.5. Y-intercept, where does it cross the y-axis? 3. So my y-intercept is +3. Let's look at a few new terms. Few new vocabulary words for you. Zeros, roots, solutions. They all mean the same thing. It's when a graph is graphed by itself, the location of the x-intercepts will result in the function solution. So another word for zero, roots, and solutions is x-intercepts. So if you find your x-intercepts, you found your zeros, your roots, and your solutions. So the solution or root of the graph we have here, let's find our x-intercept. Our x-intercept is -1. Therefore, our solution is -1. Our zero is -1. And our roots are -1. Next thing we want to look at is intervals of increasing and decreasing. Always read the graph from left to right. Use the x values. Use the x values, guys, to describe the intervals. As the graph increases, that means x values are getting bigger while the y values get larger. As the graph decreases, that means the x values are getting bigger while the y values are getting smaller. If a graph is constant, then the graph is horizontal, so the x values are getting bigger while the y values stay the same. So let's look at an example. So let's identify the intervals of decreasing or increasing here. Let's look at this graph below. Let's read from left to right. This graph is going down, which means it's decreasing. Where did it start decreasing at? Negative infinity. Where does it stop at? We want x values to here go up. That x value is negative 2. Now let's look. The graph started going up. That would be increasing. Where did it start going up? Negative 2. When did it stop going up? Well, it never stopped. So positive infinity. Now let us look at end behaviors. End behaviors, what is the graph doing on each end? So we have two ends. We're going to read from left to right, so we're going to start at the left side. From here we have this left side. What is the graph doing on the left side? As x goes to negative infinity, the y's are going to negative infinity. The right side. What's it doing on the right side? X is going to infinity, y is going to negative infinity. X's are getting bigger, y's are getting smaller, going down. Most functions have some type of critical point or value on their graph that is observed to help determine various features. Absolute value graphs have a vertex at the point of the V. If that point is monitored, one can determine the shifts. The critical point is often determined by using the following format: y equals the absolute value of x minus h plus k, where the vertex is at the location opposite h, k. Notice h is used for c, k is used for d. Find the vertex for absolute value of x minus 3 plus 1. So we look inside. We want opposite of negative 3, which is positive 3. And then we take the outside number, which is positive 1. So our vertex is at 3, 1. Let's look at a few other graphs. The piecewise function first. It looks at like pieces, 2 different pieces. We could have 3 pieces or multiples. The one on the right looks like we would be walking up steps, so we call that a step function. Alright, let's analyze the graph completely. So everything we went over so far, we want to find for y equals absolute value of x plus 4, subtract 3. So the first thing, let's graph it. Kind of hard to do anything unless we graph it. I know that this is down 3 units because of the subtract 3, and then I'm going opposite of plus 4, which is minus 4, so left 4. Now that I have a v because of the absolute value function. Okay, first thing we wanted to find out is what is the domain? And then the range. Domain is my x values. So where does it start? Read left to right. Where does it start? It starts at negative infinity. Where does it stop? Keep going right. Where does this graph stop? Well, it never stops. Positive infinity. We could say all real numbers. That's the symbol. Or we could write all real numbers. Alright, let's look at the range of my y values. From the bottom of the graph, what's the lowest value here? Lowest value is negative 3. We're going up. How far does the graph go up? It goes up forever. And negative 3, there's a closed dot, so we got a bracket. We also could write this as y greater than or equal to 3. Next thing we want to do is my x-intercept. Where does this graph cross the x-axis? Can we tell? If we keep going up 1 over 1, looks like we're going to be at -1. Up 1 over 1. And we're going to be at -1, 2, 3, 4, -7. We could have also done that algebraically by substituting in 0 for y. Y-intercept. Let's do this one algebraically. I'm going to substitute 0 for x. 0 plus 4 is 4. Absolute value of 4 is 4. 4 minus 3 is 1. It's going to cross the y-axis at 1. And we also could write that as an ordered pair. 0, 1. Now let's look at determining the zeros. Solutions and roots. Remember, all three of these mean the same thing, and they also have the same definition as the x-intercepts. So my roots are -1 and -7 for all three. Now let's look at the interval of increasing or decreasing. Read from left to right. This graph starts by going down. So we are decreasing. Where are we decreasing? It starts at -infinity. Where does it stop decreasing? Here. We want the x point, -4. Now we're going to do increasing. The graph starts to go up. Where does it start? -4. Notice these 2 point numbers are the same. Why? Because it stopped going down and started going up at that point. Where does it stop going up? It never does. Going to positive infinity. Now let's look at NDA. So what's the graph doing on the left-hand side? As x approaches -infinity, what does the y's do? They're going up to where? Infinity. Now let's go over right-hand side. The x's are getting bigger. As x approaches infinity, f of x approaches up, it's going up to positive infinity.